Yeah, you can start now.
Okay. Okay, we'll start now.
Hmm.
Good evening, everyone. I'd like to extend a warm welcome to all of you for today's talk. This marks the beginning of day 4 and the last talk of Curry Leaf Days 2023, organized by Curry Leaf, a math club of MTTS alumni in collaboration with MTTS Trust. Today, we have with us two colleagues, pair of finest professors of MTTS, Professor Satyanarayana Reddy and Professor Ambar Habib, as the speakers for today's talk. We welcome you both. Over to you, Asta.
Professor Satyanarayan Reddy, who is an associate professor of mathematics at School of Natural Sciences in the prestigious Shiv Nada University of Eminence. He completed his PhD from IIT Kanpur. His research interests are algebraic graph theory, combinatorial matrix theory, and algebraic number theory. His profound expertise and dedication to mathematics have earned him a prominent place in the academic community. He has been long associated with MTTS and is one of the main faculty there. He has made significant contributions to the MTTS program. Our second speaker for today is Professor Ambar Habib. He is the professor of mathematics at the School of Natural Sciences in the prestigious Shiv Nada University. He completed his PhD from the University of California, Berkeley. His research interests are representation theory, Lie groups and algebras, and mathematical finance. He has authored several books and book chapters. His deep knowledge and unwavering commitment to mathematics is immaculate. I now invite Professor Satyanarayan Reddy to provide his valuable insights on the career possibilities that exist within the field of mathematics. Over to
Before
Thank you,
diving into the talk,
Hmm.
uh, I would like to bring these basic instructions to the audience's notice. Kindly feel free to ask questions. Please refrain from unmuting yourself until you are asked to. Please use the raise hand option given in the Zoom to ask questions. Over to you, Satya sir.
Okay, thank you. Thank you, Asta. Thank you, Karilif people, giving this opportunity. Today we are just telling few things on career in mathematics. Of course, as you know that it is difficult to cover all the things in just in short time. So we'll just glimpse of the where mathematics can be used, what mathematicians can do. So that jobs automatically comes by that approach. Okay. So this is the way. So we are giving different applications of mathematics in various fields. Then also at the end, we will tell about where you can go after BSc, where you can go for higher studies, after MSc, where you can go for higher studies. And also those who are in BSc or MSc, they are pursuing. So for them, where are the summer program they can attend, things like that. And these are also, we are not exhausted entire list. We are giving few of them. Yeah. Okay, so while your interest in mathematics may have started as a hobby, it is possible to make your love of mathematics into lucrative career with your right amount of skill and effort. So these are important. We need to choose a skill and also efforts are required, of course. So we need to excel in one of the fields so that then only jobs are possible. That's what my right amount of skill meaning here. So I'll explain those in a while. So, before going further, it is better to mention that what is a MTTS contributed in this in this respect. It is worth mentioning the success of MTTS participants in the job market. So, Professor Kumarasan's consistent efforts transformed mathematics education in India significantly. So, if you take any primary institute in India, one can see a few mathematics faculty were once participants of MTTS. On an average, if you take whatever institute you take, on an average, at least one participant will be there as a mathematics faculty. And also, few participants occupy highest positions in other organizations as well. Not only jobs, MTTS provides immense confidence to tackle day-to-day problems of work and life. So those who are actually in the worst cases, so those who are actually some problem came, they not pursued higher mathematics because MTTS training will help them that they can start mathematics tuitions or something. I'm telling about the some cases where some difficulty is there. In those cases also mathematics helps like a mother, at least it takes care of certain essential things that is always there with mathematics. That is a crux of this mathematics subject. MTTS is part of skill development in India in the last 33 years. So we are talking about skill development, but MTTS is one. It's clearly doing that job from the last 33 years. So I'm starting with one problem, that one news, yesterday's news. So from one person from Assam, Dibrugarh. So his messaging app sold for 416 crore rupees. This is happened yesterday. His name is Kishan Bagaria. So he prepared an all-in-one messaging app developed by this 26-year-old Dibrugarh boy. So there is a company called Automatic. It is a parent company of WordPress and Tumblr that made acquisition by purchasing this. The app is text.com. The app is developed by Krishna Bagaria, right? So it is just an example. So like him, if you want to become famous, generally we think that how to become overnight famous and get a lot of money, right? So is it possible with mathematics also? Yes, it is possible. So there is if you want to become immediate famous, of course it is not that these problems are difficult to solve. So there is a institute called Clay Mathematics Institute. So they listed some problems called the Millennium Prize problems, right? If you go to that website and you can see those problems. So if you solve any one of the problem, you'll get the $1,000,000, US dollars, right? So it is worth mentioning at this juncture that so there is a person called Paul Eredosh. You know, he's a great teacher and great researcher. So he collaborated with many people. He used to go from different countries. So all his money he gave for the problem solving. So depending upon the difficulty of the problem, he allocates some prizes to that problem, right? So so uh, so that some problem may be $50, some problem may be $5,000, like that. So one of the problem I listed here, it is not that this problem I want to specify. I want to tell about Paulo Redosh. Whatever the salary he got, he actually given to solve problems, for encourage, motivate so many people in mathematics. That is like that. Now many people are there. They are offering lot of prizes for open problems. Once you solve, will get lot of money, and also will become famous. So, for example, in 1976, in a talk to memory of his lifelong friend, collaborator Paul Thurans, Paul Eridosh offered a prize of US dollars, $3,000 for this again earlier problem, arithmetic progressions. Okay, one can visit Wikipedia website to know this problem. But as of now, in 2008, this is become now $5,000 in 2008. Present at this moment, I do not know how much it is increased. Yeah. Any questions till now? Okay. Yeah. So there are other places, prizes are available, Hutter Prize, Beale Prize. You can visit this website, Unsolved Problems and Rewards, right? So in this website, so many problems which are already uh, stated, and some solved, some unsolved are available here. Some of them are solved also. They are also available here. You can see some history about the things. And in particular, I liked this website, Maths Overflow. In this particular website, you go, then lot of problems they listed, and monetary awards, rewards were listed there. Okay, not only these things, there are many other problems with or without prizes. For example, you look at the Goldbach conjecture. Maybe prize is there, I do not know, but it's very well old problem, and they are easy to state also. If you solve that problem, then you automatically become famous, and later you'll get lot of prizes. Even there are no prizes at this juncture, but you will get lot of prizes later. And also you are observed in a good institute, obviously, immediately after that, right? So this is these are some of the things in general for uh, so if you work very, very hard in mathematics, you completely believe in mathematics and all, where you can go, where you can become famous, like that. These now we are now go to general people. In general, just you took mathematics and other courses also, but you finally want to settle down how mathematics will help, right? That we will going to start now. So now Professor Ambar Habib will say a few things about this slide. Amber sir?
Sorry, I was muted. Yeah, so this is part of when I talk about how maths gets used nowadays, and you can see it in so many places. And so, I mean, something we are always doing is we are always typing something into Google, or if you're on a phone, you might be speaking into Google and trying to find out information. Okay. Uh, so, so suppose you do that. I mean, suppose for instance you wanted to find out MTTS about MTTS, and you typed in its name into Google, right? And so immediately you get a lot of responses back, a list of web pages where you can go and find information. And there are two things about this that I find especially interesting. Okay, one is how useful this information is, right? Because it really tends to take you to the right places where you will find the most reliable and the greatest amount of information. For MTTS, it takes you straight to the main MTTS website, as opposed to some newspaper article about MTTS or some other site talking about MTTS. Takes you straight, the very first option it shows you is the MTTS website itself, and it also provides you a summary of the subpages and what you can find there. And then below this, you will find other references to MTTS of other types and to specific programs. So that is one, that out of all the information out there, what analysis does it do to get you the right stuff, the one that you need? The other interesting thing about it is this thing that has been highlighted on top. I think, what does it say? There's something like about 51 million results in 0.28 seconds. So that is the scale at which it is working, right? It's working with the entire available web, and it's crawling so many websites to see what it can find about MTTS. It's generating millions of results, and then it is sorting through them and giving you what you need. And it's doing all this in just 0.28 seconds. So that way it becomes very interesting. What kind of problem is this really, right? Is it just a huge computing problem that is solved by just using lots and lots of computers and servers and so forth? And one can go to the Google webpage itself and search a bit, and you find some sort of summary information there about the scale at which they work. But the thing that's interesting is that they also tell you at different places what kind of mathematics they use. Now, this basic algorithm that you do to do the ranking is the PageRank algorithm. That is basically linear algebra, and the solving of large linear systems is the issue here. So your normal routines that you do by hand for small systems won't work. Here you will have hundreds of thousands of rows and columns. Then it uses all sorts of other things because it doesn't just do search. They have to target ads to the right people, or somebody wants to speak into it instead of typing, so they need to have voice recognition. Okay, they need to price their ads, so they use linear algebra, they use game theory, they use probability and statistics, they use time series analysis. Google Maps uses geometry and graph theory to optimize, what route you should take and to estimate how long it will take you. So there's all sorts of mathematics that is involved, that is behind the scene in just this simple looking picture. And that is fascinating. And what is also fascinating is that, all this mathematics is not just useful for Google, it's used in many places, the same mathematics. So it's used to model the spread of diseases. It's used by biologists to do their genetic analysis. Signals processing is used everywhere. So I won't go on and on. The point is that through Google, one sees how mathematics really is a part of our real life and advanced mathematics, not school mathematics. But at the same time, at the undergraduate level itself, you can appreciate all these kinds of areas in mathematics. You can learn about them, become proficient at them. And by the end of your degree, you can be in a position to apply them to problems and get either jobs or go on to good higher study programs out of that. Okay, Satya.
Yeah. Okay, sir. Thank you. Yeah. So there are few applications now. So in particular, some work in interested in statistics only. So the statisticians have a lot of jobs now. Okay, they are employed in various areas like population statistics, crimes, healthcare, business, accidents, insurance, and politics, etc. We'll try to explain these. So their main job role is to interpretation and analysis of data. In some cases where data collection is required, they may even part of the acquisition, questionnaire design and collection of data. So they will do all sorts of these. And even statisticians do statistical designs to optimize things. So we'll discuss those aspects one after the another. So for example, economists, uh, they use mathematics very heavily. So in particular, they monitor economic trends and make forecasts by researching, collecting, and analysis of data, right? And the data analysis. Now, recently, this is a buzzword, right? Analysts process and analyze such data, draw patterns and conclusions for making business decisions. Every business produces such data in their day-to-day operations, but it is the job of data analysts to make sense of it and get it to a form where it is of use in the building business strategies. You know that, for example, you purchase few items from Amazon or some other Flipkart or some other market, then automatically they recognize that where you are interested in, right? So that is exactly these data analysts are doing. Now, whenever you start opening, then you automatically will pop up with some websites. So they already recognized that where you are interested in, right? So these are the some of the things data analysis and actuary. It is a field of actuarial science. Is one that deals with risks of all kind, be it is a financial risks or insurance risks or business risks, right? In particular, when COVID comes, then people are now worried about more about health risks. Earlier, health insurance is not much there. Now suddenly, health insurance become famous. People are now realizing that health insurance. So this is the area actuarists, those who done degree in actuary, so they can be helpful. They help solve complex problems for companies and help them to develop the policies, because these policies are important, right? Means they are they are offering a lot of amount when something happens, but they need to have that, they need profits also. So this actually person will takes care of those aspects. Okay. So another big area is that operations research. So as you know, everyone, our goal is to optimize things, right? So operations research analyst is the responsible for solving complex problems, dealing with efficient allocation of resources such as materials, workers, machines, time, and money, right? They apply mathematical techniques to improve business strategies, operations in areas such as distribution, transfer, scheduling, lots of things, right? In all these things, we have a problem that we need to optimize. That means whether uh, maximize or minimize things, but restrict constraint to certain restrictions. So there is operations which is very useful. Even many mathematics undergraduate students, graduate students, they will go to MBA, right? There, this operations research is very useful for them. Okay. So these are some of the things for the statisticians are doing. Still, I am not put everything. So even you know that in the natural language processing and content recognition, so many areas are there. Data mining, there are many areas now. Statistics is applied. So as I pointed out earlier, it is difficult to tell everything in a short time. Okay, another area I want to emphasize is signal processing. As Amber Habib already mentioned earlier, signal processing is a complete application of mathematics. It uses Fourier series, Fourier transforms, linear algebra, matrix theory, function analysis, number theory, and many more. Okay, so fast Fourier transform (FFT). So it is a method which convert time domain samples to frequency domain. The continuous time domain samples were converted into using converted into discrete domain by using discrete Fourier transforms. Right? The method which converts at a faster rate by using fast Fourier transform. while processing time domain samples to frequency domain, the required number of multiplications, summations are less in fast Fourier transform. This is a very good algorithm which actually applied in various variety of applications, such as audio processing, image processing, signal analysis. Actually, this revolutionized mobile communication. Once this fast Fourier transform algorithm came, now we are able to use mobiles, and that revolution started. Cost is reduced and all. Right now, there are many other applications like they are applied in image compressions and whatnot. So everything I am talking now, it is through signals only, right? So signal processing is very big area where mathematicians can work. So that is what we told earlier, that the skill, if you develop, if you concentrate, you more work on these areas, then you can apply for jobs in this respect, in the image compressions and many other things. So yeah. So other area which mathematicians will work heavily, mathematics is used, is that related to coding theory. So there is a one paper that revolutionized this concept. This paper led to many areas in information theory, coding theory, communication theory, so many areas. So mathematical theory of communication, this paper in 1948, published by Shannon, showed that given a noisy communication channel, there is a number called capacity of the channel, such that reliable communication can be achieved at any rate below the channel capacity if proper encoding decoding techniques are used. So around 1948 onwards, this particular area started. So now I am talking, you are completely listening to me without any noise, right? This is possible because of the applications of this coding theory, information theory. This marked the birth of coding theory, the field of study concerned with the transformation of data across noisy channels and the recovery of the corrupted messages. So this is the history, when it started, how it went and all, right? So there are so many codes developed in the process. Recently, Polar codes, they are very much used in 5G networks and all, right? So it is completely full of mathematics. I'll explain through one of the example. So actually in this Hamming and Shannon, they both work in Bell laboratories. Both are colleagues, but they developed independently so many things. They are the person started actually this error correcting codes. Okay, so how it goes, it's actually like this. So the basic problem in coding theory is like this. We have a message, say length X. So we cannot send as it is. We need to encode it. That is called code word. That is now become of length N. Clearly N is greater than K, right? So why you are increased the length? If you increase the length, what happens? Even if it is corrupted, right? The code word is corrupted. With some entries maybe got deleted or changed, etc. Still we can recover. So the goal is that given a C tilde, find my original message X. Hope this part is clear, right? So now the technique that how to convert given message to code word and again code word to the actual message, this entire thing, coding, decoding, these are the process involved. Here completely finite fields, linear algebra techniques are used. So some of them who done already coding theory, they are aware of these things. Okay. In particular, so one example I want to give you. So you have a binary strings of length K, right? So binary string of length K. So Alice want some message X, she would be sent to Bob, right? So it is famous that in cryptography, coding theory and all, these are the people, right? Alice and Bob will be famous. So Alice is sending some message. So Alice encodes her message as C, right? Now Alice sends C to Bob over a noisy channel. Bob hears C tilde. What Alice mean to say? So this is the idea, right? So but because of the techniques what we have, we can get complete information. Think of so in the slide below I wrote. Think of how we get messages from moon or satellite images and all, right? Now Chandrayaan we sent, but that is far away place. So the signals it is sending, now we are able to get entire data only because of these codes, Reed-Muller codes. There are several codes people use it. Okay. So another application of this coding theory is that so you store data, right, in pen drives. And earlier, of course, now people are not using the disks. So this only idea for that I gave. So you have a disk and some corrupted, or then again we'll get the entire data. For example, now digital money payments are started. So you go to some shop, there you have this QR code, right? QR code also there are a lot of repetitions. Even some part is not corrupted, still we can get. You see that when you put your mobile, it absorbs a part of it only, not entire thing immediately will pay the money, right? So these are all happening because of the coding theory part. Even our day-to-day life, our banking and all, you know that HDFC Bank, SBI Bank, they have a fixed number of digits in their account number. So some corruption happened, some by mistake one digit is changed to other digit. So it is possible to recover things. Okay. So sometimes you entered extra digit also. So that can be recovered. So there are a lot of techniques people use. Okay. So it is possible, right? When you are typing, suddenly you increase one digit extra, or you interchange it to digits while you are talking to phone your friend. Sometimes there is a possibility that you say 60, but the other person thinks 16. But there are codes which recognize them where there is an error. So there is a modulo 13 error, EAN error, many things are there. Barcodes and all these coding theory will help in that. Lot of things are happening in the world, entire world. Some places even they started that if you go to a shop, so now no need of people to at the end give the price and all. When you go inside, automatically in mobile there is a scan code comes. You go to particular item, you scan it, automatically it will go to your account. Money also deducted. You just simply walk out from the shop. These things are going to happen in future. Even in US, you enter and so there no need of in airports and all. We go like bus, our airports, like in our buses and that one. You go in and come out. They are actually improving a lot there. So surely it will happen in India also. So then other area is cryptography. So cryptography is science of keeping secrets as secret. It is in the beginning the cryptography intention is this, but now their applications is changed a lot. And you know that Ramanujan worked with the persons. So yeah, so I'll go to that history later. Okay. So assume that a sender referred to here, Alice, okay, wants to send a message M to a receiver called Bob. She uses a insecure communication channel, earlier noisy channel. That's their objective is different. In coding theory, security, insecurity is not the matter main there. Only their noise and so we need to get originally. But here, our channels themselves are not secure now. How to get they may be corrupted in between. Some people are corrupting it. That is happening day to day our life, right? So how to do that? So she uses an insecure communication channel. For example, channel could be a computer network or a telephone. So there is a eavesdropper. So they will change your data. Then how do we tackle these problems, right? So our day-to-day digital payments also, e-commerce, cyber security, these are all applications of these, right? Okay. So there is a problem if the message contains confidential information. The message could be intercepted and read by eavesdropper, or even worse, the adversary, as usual referred as Eve, might be able to modify the message during the transmission in such a way that legitimate recipient Bob does not detect the manipulation. Right? One of the objectives of cryptography is to provide methods to preventing such attacks. The fundamental and classical task of cryptography is the confidentiality by encryption methods. The message to be transmitted It can be some text, numerical data, or executable program, or any other kind of information such as called plain text, right? So Alice intercepts the plain text M and obtain the ciphertext C. The ciphertext is transmitted to Bob. Bob turns the ciphertext back into the plain text by process called decryption. So here I gave two functions. Actually, encryption, decryption also functions. Here in encryption, the domain is key space, plain text space. Okay, they will take one key1 and one message, and they convert it into, this function converts into ciphertext. Decryption is again a function. Here the domain is key space and the ciphertext space, right? They will take key K2. So of course, K1, K2 are related. Otherwise, decryption is not possible. And the ciphertext, they will give the plain text back. Okay. So to decrypt, Bob needs some secret information, a secret decryption key. Adversary Eve still may intercept the ciphertext. However, the encryption should be guarantee the secrecy and prevent her from deriving any information about the plain text from the derived, observed ciphertext. That is the goal, right? But this is actually earlier what happened. So the key and the LI side and Bob side is same. That is called the cipher symmetric cryptography, right? But if the key itself, while sending key itself, it is taken by eavesdropper, then everything is collapsed, right? So there is a process called asymmetric cryptosystem came. So in 1976, Diffie and Hellman, so in the famous paper, the New Directions in Cryptography, they introduced a revolutionary concept called public cryptography. Here what happens is that they will send the key. That is first process is called key exchange. One can exchange the key without other person can get it. Okay, so these are the techniques. So I cannot go into details, right? So there is a technique called, we can first interchange the key exchange protocol. I will tell you, I'll give one example so that this entire thing, whatever it is given here, you can understand it. For example, we are aware that cyclic groups, right? Cyclic group means it has a generator. So in particular, you take ZP, where P is very, very large prime, okay? So ZP minus 0. So you know that this is called UP, right? Units in the ring ZP. That is a cyclic group, right? That it has a generator. So now the publicly Alice can announce that G and P, she is using G and P. G is the generator of the group and P is the prime number. It is known to everyone. Whoever eavesdropper, everyone it knows. This is called public parameters. Okay, what is the problem here is that, so you take some element A from 2 to P minus 2. I tell you the reason why we not take 1 and minus 1. That is easy. Because 1 is a identity element, so it is easy to recognize, and minus 1 also, minus 1 square is 1, its order is 2, we know that. So we'll avoid those two numbers. Then 2 to P minus 2, right? We are in ZP minus 0, so 0, 1 to P minus 1, but we are removed 1 also, and P minus 1 also. Okay, what is means by A belongs to R here? R means random. We choose some random number from 2 to P minus 2. So Alice will choose random number, and she computes G power A modulo P. Okay. Now Alice only know A. No other person know about A, right? But she computes G power A. Now she will send that to via channel. Now Eve know G power A. She cannot get A from G power A. That is called a discrete logarithm problem. So the Diffie-Hellman, they given that a discrete logarithm problem is very hard. There is no polynomial time algorithm to get it. But now later these other computers come, so quantum computers come, that they may solve. But right now it is a very hard problem. So if you get G power A and she want to compute A from it, it takes years to get A. So by that time our job is completed, right? Okay, so G power A will be transmitted. So Bob receives A now, right? And Bob also chooses some random B from 2 to P minus 2. He will compute G power B mod P. And Bob sends B to A, Alice. right? Now, what Bob will do, Bob knows A that came from Alice and a random B, right? This chosen by Bob itself. So A power B, Bob will do. A power B means A is G power A. So it becomes G power AB. Now Alice get B from Bob, right? So, and A known to Alice. So she will do B power A. So now G power BA, G power BA. So key is now shared between them. But in between, no one can get A and B while it is going. Even Alice cannot get B from Bob. Okay, and Bob cannot get. So one advantage of this is that this can be used for multiple partners also. Okay, yeah. Okay, so that we will not go into detail, but this is a nice thing that how number theory is used, right? Okay, so and you know that so I gave two examples, three examples: signal processing and coding theory and cryptography. So there are many other areas where, in fact, every area in whatever the field you take, mathematics is applied, right? Okay, so the use of mathematics in computer games, you are aware, and you can visit this website. You know that how mathematics used in computer games. Now, recently, how to teach other areas by using computer games also becoming prominent. By using computer games to teach something, right? Applications of graph theory in optimization problems are numerous. For example, vertex covering. Vertex covering is that what is the smallest number of vertices such that all edges can be covered. This is very useful. For example, you go to some museum, they'll put web cameras. We have to use minimum web cameras and we need to watch everything, right? We need to put minimum police and they have to watch everything. So these problems are vertex covering problems will solve those techniques. Vertex coloring. This is very much used in scheduling things, right? Similarly, star test path problems, right? So few more applications of graph theory are social networks for Facebook networks and all. So Facebook, the person who have more friends, if you contact them, then our business will go, right? Social networks. So in the graph theory point of view, the person who has maximum degree is a right person to contact, improve our business. So graph signal processing now recent editions in this, as clearly sir already mentioned, Amber sir. So in epidemiology and disease spreading, so graph theory is applicable, very useful. Even in electric circuits, this is the beginning area. Electrical circuits, they introduced actually Laplacian matrices and other things in graph theory. So so even planar graphs and all, they came from the electrical circuits only, and VLSI designs. And there are many areas actually, applications of graph theory now. It is spreading a lot. So applications of non-negative matrices. So as Amber sir mentioned earlier in the Google page ranking, so non-negative matrices, in particular Perron-Frobenius theorem, they are very useful. So Google page ranking, many areas, in image processing, bioinformatics, even graph theory, that Laplacian matrix is used in RNA double structures and all. So in the bioinformatics, a lot of applications of matrix theory is there. So in data analytics, of course, these are all worth seeing. So many people are familiar with mathematician academia. So today, actually, we are not touched that. But mathematicians also work in many other areas, fields like including astronomy, space exploration, climate study, medicine, national security, robotics, animated films, and Bezier curve, how car design influenced by the CAD designs. Here I want to say one point. You all know that approximation, Weierstrass approximation theorem. So we prove by Bernstein polynomials. There you see that what is the statement of the theorem, right? Every continuous function in a compact interval can be approximated by polynomials, right? So in that proof, we use Bernstein polynomials. Those polynomials are used in constructing Bezier curves if you confine to closed interval 0, 1. These Bezier curves are very useful now in computer graphics and designing of the car models and many areas. Animated films and all, actually, they are very much influenced by these Bezier curves. So one can look at computer graphics applications of linear transformations and all one can look into, right? And there are wide range of business applications we already mentioned, but there are two papers or posts one can visit if they want to know more about them. Theory into Profit, one Microsoft Investments in Mathematics by Ellen Jackson, and also Notices in of the AMS, Mathematical Experience in Business, Industry and Government by Phil Gustafson. So, they are available. Now it is clear that it, it that it is difficult list all areas where mathematics is not used, right? Mathematics is everywhere now, right? There are a lot of interdisciplinary things are coming. So even in health issues, so in order to clustering things, right? So mathematics used everywhere. So numerical analysis also. So interpolation, extrapolation. So your satellite is now moving where it can be in after 5 minutes. That can be estimated, right? You went to physics lab and you took some experiment. You record data in the intervals, right? After every 5 minutes you will interval. But you want to, after completion of your experiment, you want to know in the middle. That can be done by using interpolation techniques, right? Yeah. So like that, wherever area you take, mathematics is applicable, right? So I request you to look at this website. Even if time permits, now you can type this particular website. It is listed in the box, so that there you can see the lot of applications where it will be worked. It is listed in Sham's publications list. Okay, I hope one of you can try now. So type this and see that. So can you tell me, any one of you typed it? Okay, right. So these are so now I am about to end here. This is related to where are the places where mathematics can be applied, right? After COVID, in fact, medicine and other places also people are using mathematics, right? Okay. Now we'll go to the thing. Those who are actually now doing a BSc second year, third year, and all. So what is that you want to do? Where you want to apply? So higher studies, what is that you have to do? So you all know JAM exam, right? So JAM score is used in admission to various postgraduate programs such as MSc, MSc Tech, MS Research, MSc, MTech dual degree, MTech PhD dual degree, right? So there are these are across multiple disciplines by primary institutes across the country. So one JAM exam you write, so you are eligible for many institutes with one exam. So this is you are already familiar, I hope. And ICERs are separately, they will conduct exams. And there are central universities. Once you are not get good score in JAM and you are not selected any ICER, then go to the, you can even apply central universities also. I'm telling various sources. Central universities also, they conduct one exam. So common entrance test. You are eligible for all central universities. You can go for higher studies there. And there are NBHM fellowships. You write that exam, and if you qualify, so you will get stipend every month. Wherever you join, you'll get at least some around 5,000 per month. It may be increased now, so you'll get it. And here I wrote MMC. Those who are in second year and first year, Madhava mathematics competition, you can write that exam. So they further take you to the nurture programs and they train you, right? So ISI admissions, ISI Calcutta, ISI Bangalore. So there are some ISI separate admission tests they will conduct also, right? So there are many other private institutes are there. So one can look for. Yeah. Now I'm going to some summer programs. So one of the main thing is MTTS. MTTS summer program is 1 month. You are all aware. So nice program. They will take care of your accommodation and travel, everything here, right? Other summer programs are HRI, Harishchandra Research Institute, Allahabad or Prayagraj. So there is a SPIM program, summer program in mathematics. So please visit that website and you can apply and you can attend program there. Now NICER Bhubaneswar also recently started summer program in mathematics. And IIT Gandhinagar also recently started. So there is a promise in India. It is a 6-week summer program for mathematics aspirants. This program is held in Ashoka University, Sonipat, Haryana. Secondary and higher secondary students can participate. Yeah, so this is one place. And there is something called Epsilon Camp. One can visit, and age group of 9 to 13, they can attend this. You can tell to your brothers or sisters, they can attend these last two, right? And IMSC summer camp also there. If a bachelor or master student is interested in research in areas of theoretical physics or mathematics or theoretical computer science, I forget to mention earlier, there is an exam, JEST exam also, JEST JEST, that is a free of cost. If you qualify for that, then you can go to theoretical computer science. You can do in IMSC Chennai. Yeah. Okay. So the IMSC summer camp. So you can visit IMSC Institute in the summer vacation. IMSC accepts students through summer program organized by Joint Indian Academics of Science too. Okay. So you can visit this website and look at things. There is another event, VSRP program, Visiting Students Research Program. It is conducted by Tata Institute of Fundamental Research. So it is a best place again to go. And ICTS, Summer School for Women in Mathematics. Even recently, IWM, Indian Women in Mathematics, they are conducting so many programs, regional camps and main camps. So in particular for women students, they can visit IWM, Indian Women in Mathematics, and so I think I listed that also. Okay, not listed. Yeah. So you can visit that and you can have there. So Kush Raho. This is my supervisor actually, Arun Kumar Lal always says Kush Raho. So I'll end with this. So if you have any questions, so then I'll keep slides for some time. Otherwise, I will stop sharing slides. Okay, so no questions. I'm stop sharing.
Oh, sorry, sir. I didn't realize I was unmuted. I was on mute. So, yeah, it was a well-structured and an engaging talk that not only highlighted the diverse career paths available, but also provided the practical guidance in how to navigate in the complex world of mathematics. So, over to you, Sushrit.
Thank you, professors. It was a great talk. Your talk not only shed light on wide array of career opportunities within the field of mathematics, but also helped us in understanding how beautiful those career opportunities are. So we have a questions which we received from the audience before the talk. And we also have a bunch of questions in the chat box as well as on the YouTube live streams, which I would like to share with you.
But before that, I just want to ask something that
yes, sir.
Mr. Hambar Abi maybe want to share something before actually go to the questions.
Sure, sir. Sure.
Yeah. So, Hambar sir, do you have?
I think let's have the questions.
Okay, sir. Yeah. Okay.
Yeah, because I think that's always the most important part.
Yeah.
And whatever I have to say, I'll find some way to say it while answering that question.
Correct.
Okay, sir. So there's a question which we received long before. So can you do research in mathematics as an undergraduate? And if yes, then how should you proceed?
Okay. So, yeah, actually, in undergraduate, we have in our university, we have undergraduate program, BSc in research. That is luckily it is a 4-year program. Okay. So I tell my own experience. So, one of the student, I have actually some almost 6 papers right now with undergraduate students itself in various journals. So I'm just sharing my experience, but how it went, I want to share that. One of the student is Abhijit Jayantan. In one of my number theory class, he asked a question that, so you may know aware of Euler phi function. It counts the number of integers which are relatively prime to n. Then he asked a question to me that I do not want to count all the numbers from 1 to n. I only count numbers which are composite numbers which are relatively prime to n. For example, if I take 10, so what are the numbers which are relatively prime to 10? So 1, 3, 7, and 9, right? But now I do not want to count 3 and 7. I only count 1 and 9, right? So that he asked the question. Then I came back to my office and I wrote some Python program and I listed all the numbers. I created bunch of data and again I give it to Jain Abhijit. So please go through this data and come up with something. So then later we keep on working in this on that problem and and it came very nicely and that work we published now. It is published in Mathematics Student. Later that sequence which we got, that is a new sequence. It is not available in Encyclopedia of Integer Sequences. Somebody put our paper there also. Means that sequence they added now. Okay, this is one work. With others, so actually what happens, how it goes is that you can visit one of your professor, okay, and they can suggest some problem. Slowly it will as days progress, you will first the instructor may give you a small problem and he knows that what is the next question to give it to you. Slowly he will build up and you also start thinking, you also start asking questions yourself. That way over a period, means when you after your first year you go and talk to the instructor, 1 year completed, another 2 years you may stay. If it is a 4-year program, you will stay for 4 years. You start interacting, then summers and other times, so there is a chance that you can work in that problem, right? So other question we discussed we have is that instead of determinant of a matrix, we have a permanent. Means permanent of a matrix means if all are sums actually. Instead of minus, the determinant we have, you know, that plus and minus will be there. We'll add everything, right? All are plus. Then that does not have a very nice texture like determinants. It is not multiplicative like that. Then we worked on a problem that you take Zn and like GLN of Zn, GL2 of Zn we took and we computed the permanents and again we do modulo n. Then we counted how many have permanent 0, permanent 1. That is 2 by 2 matrices we worked. Okay, that is published in some undergraduate journal. Then later we increased it to 3 by 3 matrices. Right, then that is published in Integers. There is a good journal in number theory. So like that, okay, the point is that it will go slowly. So you take some problem and keep on adding things to it. Yeah. So yeah, this is the thing I want to. If you want more questions later, I will come back to more problems also.
Okay,
Yeah,
sir.
Amber sir, you want to
So
add something to it?
I
yes,
think, basically, I think the first thing that Satya said, no, I mean, the student asked a question. So, I mean, there may or may not be research may or may not happen in the sense of you necessarily getting a publication. But the most important thing is that you form this habit of, asking the question, trying to formulate a question. I mean, not just usually the questions we ask the teachers are, I didn't understand this, can you help me understand this? But if you can come up with questions beyond that, make the effort to ask questions beyond that, to speculate, to guess, to wonder if maybe something extra could be true or not. Or, I have counted this, but can I also count something else? So, because I think research is a lifelong thing, the hardest thing is getting started with, this habit of formulating questions. So get going on that, find faculty that enjoy this sort of discussion. I mean, not everyone will, but, find people like Satya, okay, who enjoy students, suddenly popping up with something. And there are many, of us around who do enjoy that. So, you have to talk to the right people. So you have to, doing research involves you sort of stepping out of your comfort zone a bit also. It means that you go up to people and you ask them questions, you pester them a little bit, and you will need that all your life. So start now. Okay.
Yeah, correct. Yeah, as Sir pointed out actually, so that is a nice point that you no need to look for publication and I'll keep on working. So the So after some time, you will realize that, okay, I can ask more questions so that it build up an expository article type, right? First. So that is useful. For example, recently you take simply Jeden. So we started a small problem that how many how many units are there in it? That is known, phi of n. Then how many non-units are there? That is exactly phi n minus phi n. Then how many prime elements are there? How many irreducible elements are there? How many reducible elements are there? So you know that in ring theory, while you are studying art, obviously you look for different types of elements, right? But counting them, how many of them are there? So it's the same problem we can ask for different rings also, right? So if it is a finite ring, then you can ask for combinatorial point of view. So that while counting it, you know about more about that structure. So counting is much complicated thing. So if you count them, then automatically you will get more grip on them, right? Yeah. So to add what so you keep on asking questions and improve take one concept and keep on asking questions, keep on improving it. Do not stop it. Again, after some stage, now you may be stopped today, right? 1 month it happened. Now your exams are over. Again, come back to that problem. Your observations keep in, make a one folder and keep collect all the information and all papers related to that. Make one folder and keep them and come to that problem and again. And there should be at least one friend or person to vomit, means go and discuss. Then things will come up. Yeah. Okay. Please go ahead.
Thank you, sir. So talking about research, there's a question on YouTube chat box by Deep Thakur. He asks, is doing research uh, in mathematics, pure math, a viable source of income?
Yeah, I mean, if you ask mathematicians, then of course it is. We have jobs and we are comfortably off. So it has been viable for us. Okay. And I mean, there are lots of such jobs, but then there are different directions. Okay. So there is academic research, right? And that is right for that will help you get to academic positions and so on. But Satya was pointing out all these applications of mathematics in different areas. And therefore, you could also be doing mathematics research, not for a university or a science research institute, but for a company, for a bank, for an insurance company, financials, even say a power distribution company. So there are all sorts of places. Wherever maths gets used, they need a research in that kind of mathematics and its application. Sometimes the research needs to develop new mathematics. Sometimes the research needs to develop how the existing maths can be practically implemented. I may have a proof that something exists, but that may not be a practical thing. The practical thing would be, how do you find that thing? How do you approximate it? How do you get a decent approximation quickly? Right. So the questions could be quite different. And you need mathematicians to tackle those questions as well. Okay. So yeah, so it's viable in many ways. And of course, the most obvious thing is within the world of mathematics, but the wider thing and the thing that has grown so much in the last 20, 30 years, especially since computation became practical on a large scale, is everything else. So also what's happening today is that if the problem is important, if it's a big problem, then one type of person is not enough to solve it. So if you're trying to develop a way, to use some sort of scan to detect cancer, right? It will not be enough to just have a biologist thinking about it. You will need a biologist, a physicist, a computer scientist, a mathematician. Okay. All of these have to come together and think about it. Okay. And the mathematician will have their role in it. And in that sense, you will be part of that. So actually, on everything I'm saying, I mean, all the examples I'm giving, they have not gone into detail, but I'm picking these particular ones because they reflect people that I know, my colleagues or old classmates or students that I have taught. So if I say you can be part of cancer research, you can be part of running an electric supply company, you can be in a financial institute, an insurance company, it's because I know the so many mathematicians who are doing this.
Thank you, sir. So one of the questions that we received from the form was, can you go abroad, let's just say to an Ivy League university for a PhD with limited financial resources? And are there any scholarships in India which are specifically for PhD students?
I mean, within India or scholarships from India to go abroad?
From India to go abroad.
Maybe for the UK, there are a few. Okay, there is Rhodes, INLACs, one or two others. There's something for Oxford, the Felix scholarships for Oxford. So at least maybe not strictly speaking from India, but these are at least scholarships largely targeted at Indian students. Okay. So yeah, so there is a few for UK. I think other than that, I don't know of that.
DAD for
But
Germany.
US universities, if you go for PhD, then chances are high that if they take you at all, then they will give you financial aid, teaching assistantship at least. And then if your record is good enough, you might get a fellowship where you don't have to teach, but you go and you start taking your courses and you start doing your research. In Europe, not so much. I think scholarships are scarce, but on the other hand, in many countries, the fees are low. So Germany, for instance, hardly has any tuition fees. And so if you manage to get into their master's or PhD programs, you only have to take care of your living expenses. And there would be a handful of scholarships, but they are tough to get. So some people would get them, but most people would not. But on the other hand, you're only paying living expenses and not tuition. UK, I mean, both are high, both living expenses and tuition. So you really do need one of these scholarships to basically afford to go there. And US is basically, I think, the best bet in terms of that. If you want financial support for your PhD, then I would really recommend that you wait till you have done your masters. Do stay till that stage in India, because I think the undergraduate and master's scene in India is really very solid, very good. Lots of very good institutions, good curricula. And when you go out, you will not be lacking anything. You'll be able to do well in their PhD programs. With undergraduate, there is sometimes a discrepancy between what the undergraduate learns in India and what the expectation may be in Germany or US or UK. Sometimes there are little gaps which may be bothersome. But up by end of masters, that is quite taken care of. Okay. So when I went to the US with my MSc from IIT Kanpur, I mean, I didn't see anything that I was lacking in terms of training compared to anyone else. Okay. So whatever gap was there was my ability. Okay. There was no gap in terms of what the system had provided me. Yeah. And and I had a teaching assistantship, so I could manage. Yeah. So there are many things available. I mean, you need to, okay, so whatever stage you are at, do the best that you can, put yourself in the best situation, so that when you apply, people will look at you well, and then these opportunities are there. So Satya, I think you were wanting to say something, and I can talk
Actually, I'm saying that in Germany there is a DAD program, DAAD. They will give scholarship, and in Canada also there is a Shastri Foundation. Some certain Indian government is interacting with other governments. They are providing some financial help for certain things. I want to add that.
And one of our old MTTS students, he went to Germany and then he became a school teacher there. I mean, pure research is not the only way to get a career out of maths. So you learn enough maths, and then there are other things. So actually, I think Germany badly needs good school teachers. So they had a special program to attract international citizens. So if you were already studying there was a special program to enlist you as a high school teacher. So he's doing that, and he seems to be very happy with that. Incidentally, being a high school teacher in Germany is a non-trivial thing. So, okay. Many famous mathematicians in Germany, they had high school and basic college teaching jobs before they became famous. And they did some of their best maths in that situation.
Okay, so the next question we have, which we have on Zoom, is that we can pursue, Manmohan Sahu is asking that we can pursue a career in other fields after MSc, like biological sciences, eco, actuarial science, etc. But doesn't that require some good background in the other fields as well, other than mathematics?
I mean, if it's something like insurance, actuarial, then you basically need to learn their language. They have their own notations and terminology. So I think that is the main thing. Other than that, it's statistics, differential equations, and the like. So, you know, if you are good at the maths and you learn their language, you are set. And this works in many directions, many areas. And also, you can then go, you can take targeted degrees. So you follow up your maths education with a more targeted degree, if you are sure that's the direction you want to go in. So your master's could be in finance or actuarial or something, following on from an undergraduate degree. But even if you have a general master's, the transition is not that hard. Many people do it.
Even in elective courses, one can take those. Once you realize that, okay, I want to go in this direction after first year, you
So I
can
mean,
take
if
elective
your
courses.
institution has this opportunity, then take advantage or learn a bit online. Some things, like learning actuarial, you need to take those tests. Right. So it doesn't even matter if you have done the courses, you know the maths, you do a little bit more studying, learn the actuarial syllabi and do those tests. And if you pass, then you're set.
So we have one more question on YouTube. So it's a bit specific. So Abhishek Modi asks, Fermat's last theorem is already proved using algebraic geometry. If he proves the same by elementary principle of mathematical induction, will the new proof will also be celebrated?
No, absolutely. I mean, depends how long it is. Okay.
Yes.
The original one is several hundred pages. I mean, if you
Yeah.
can come up with a relatively short proof, and if you can, I mean, even if it's actually 1,000 pages, but it's throughout elementary, I think that would be huge. Yeah, you would be famous beyond doubt.
And even
Because
yesterday,
the current proof is one that very few people can read and understand.
yes.
So even if you have the time to read those hundreds of pages, but each page will take, a lot of effort, a lot of understanding. Probably there's just a handful of people in the world who really fully understand that. If you can create a proof that anyone can understand, even if it takes them, 6 months to do it, I think that would be a great achievement. Just give me a second, Satya, you
Yeah.
continue.
And even that at least 2 semester courses we need to offer to understand Fermat's last theorem. We need to introduce so many things. Yeah, and in this respect, I want to add one point that yesterday JSR gave one talk on primes are infinite, right? Already there are so many proofs are there. In one of the VSSP talk, one student gave talk on primes are infinite by using topological approach, right? So there are many proofs. So all of them have different advantages, right? So better to have different proofs so that there may be generalizations. For example, primes are infinite proof by Euclid may not be useful to generalize to various directions. For example, uh, primes in arithmetic progression, so Dirichlet theorem. So there it is difficult to extend the Euclid's thing, right? So Professor Ramurthy proved it in once that only by Euclid approach you cannot prove that you take any sort of arithmetic progression, infinite primes are there. But luckily later Dirichlet taken the characters and other areas of complex theory he introduced and he proved it. So even Gauss proved quadratic reciprocity law. He gave different proofs. The reason is that his intentions are different. He want to look at how prime splits in the higher extensions. Okay, so the one proof may not be sufficient. so that proof may not work. So he looked at different proof. So proofs in mathematics play an important role. So different proofs also, of course, useful, and different smooth proofs may helpful to generalize, combine things. For example, yesterday I want you to see Jaya Mehta sir's talk. So his proof very small technique only, but he combined three different proofs in as one proof. All those three proofs are coming from his proof, right? So primes are infinite have so many proofs are there still. J. Mehta sir's work is accepted. A small work that is also accepted in college mathematics. So it is possible, right? Yeah. So yeah. So, and anyhow, so Amber sir already answered clearly about pertinent to that. I just added few more points. Yeah.
Yeah. And since alternate proofs are fine, I will, what Satya was saying, I'll also say again in a slightly different way, maybe. Okay.
Hmm.
Yeah, see, I think the job is we are always trying to increase our understanding of things. So even if you, so and the proof job is not just to, tell you that something is correct. I mean, that is, of course, an important part of what a proof is for, to convince you that something is correct, but it's also to increase your understanding of that statement and everything connected. What is its place in mathematics? That is also what we would like the proof to show us. And therefore, if you have 10 different proofs, you have 10 completely different ways, perhaps, of understanding the same thing, 10 different connections. So you have a much more enriched understanding. Okay. And I think there's something we try to do all the time. No, I will give you something and I'll even give you a proof and you will not like it. You will say, why is he doing it like this? And you would want to reword it, put it in your own way. And sometimes that may be minor, and sometimes while making those changes and trying to put it in your own way, you might make it completely different. And that would reflect your understanding, and it would be useful for the world to have that as also. Yeah.
So we have a question from the Google Forms. So the question says, what are the essentials one should keep in mind while writing a statement of purpose for an application to a mathematics research program?
Okay. It's tricky because I mean there is no formal list. Okay. I mean, I wrote some statement of purpose many, many years ago, and I thought it was a clever one at the time. But after I had become a faculty and had started judging other people's statement of purposes, I thought, okay, that was a really silly one. But on the other hand, it worked at the time. So which means that basically I don't know what is a good statement of purpose, but I did write one that worked, even though if I were reading it now, I would myself not give it good marks. But anyway, you need to, something about you needs to come across to the other side. Somehow I think my statement of purpose managed that. Uh, okay, what happens is that, everyone will say, I'm interested in maths, I'm good at maths, and you might want to make promises that I will do this, I will do that, I'll do this great research with you. So the thing is, you have to somehow back it up, right? So I think statement of purpose comes at the end of a certain process where you have studied for years, and that is why it's important. I mean, of course, become good at the routine things. I mean, that is a bare minimum, but try to do something a bit beyond that so that you're able to talk about it in your statement of purpose. Okay. Give some evidence that you have studied or thought beyond what was directly required of you. Okay. And you may or may not have achieved something in it. If you have achieved something in it, that's great. But even if you haven't, but even if you have tried, if you can show that extra knowledge and that drive that you tried this, I think all that helps. So it's more, it needs to reflect you, which means that before writing that statement of purpose, you should have tried to do something a little beyond just the standard stuff. If you're writing for a PhD, for a master, it's okay. You basically want to show that you're very competent. Satya, what do you feel?
So fine, same sir, actually. Yeah, correct. Not much to add to this.
Thank you, sir. So the next question we have is from the Zoom chat box only. So Rohit Das Devre asked that there are so many things to do. How to choose the right one? He means the passion, like the thing you're passionate about.
Okay, at this point, is it okay if I show a slide?
Yes, sir. Yes, sir. Yeah.
Okay. I think this is the question I needed to
Mm.
have like to.
Yes.
Okay, so there are some examples of people and what they have done with their math degrees. Okay. Right now they can only see one. Let me just show them all to you all at once. So there's a bunch of them, right? Let's see, they all start with a bachelor's in mathematics, so that is common. Most of them have also done a master's in mathematics right away after their bachelor's and even a PhD. Okay. And so you can see that these are people who started off, doing the standard mathematical studies, but after that they diverged like anything. Okay. The first one, he was my senior in Kanpur. He was very, very good. He did his PhD in algebraic geometry with one of the top algebraic geometers. And you can see he was very good. He got a postdoc at Princeton. He got a faculty position also at a US university after that. But at some point, he wanted to move to a career in finance, and he did. He then did a MA in finance from Wharton, and now he leads the quantitative research in financial derivatives group at JP Morgan in New York, right? So that's one of the top positions in that area. Okay. And it's an interesting example because I think for till he was aged 30 or so, he had not at all thought about doing anything except mathematics, and that is all he was doing. But things happened in his life. He wanted the change, and when he wanted the change, he was able to do it. Right? It didn't take long for him to execute this shift, and then he became very good at that also. So this is my first example, but other examples will illustrate this further. I would say that do not worry too much about finding, the right path long term, that you have your whole life mapped out now, today, or even the next 10 years, you think you need to have them mapped out. I would say that you don't need to have them mapped out. But what worked for him was that whatever he was doing at a given time, he was really good at it. He was putting his entire sort of being into it. Right. So when he was doing algebraic geometry, he was putting everything into doing algebraic geometry. When he was doing finance, he was doing everything into doing finance. Okay. One thing that the PhD specifically does, it's kind of goes beyond, your technical training, is that a PhD teaches you to be completely independent. So if you do a good PhD, then you show to the world you have shown much more than just that you could do that kind of mathematics, or you could do a difficult problem in that kind of mathematics. It shows everyone that you have it in you to take a difficult problem and fight with it as much as is needed for a few years if necessary, till you have fixed it, right? Till you have solved it, till you have done something interesting with it. And that kind of assurance none of your earlier degrees provides. So I think that is one thing that a good PhD provides and gives confidence to employers of, even in other areas, to take a serious look at you. If you've done a PhD, good PhD, they know that you are an independent thinker, you are the persistence to, take on a hard problem and, stick with it until you have resolved it. Those abstract kind of qualities are extremely important, right? And employers value them. So do work that will convey this to any future employer. And don't think so much about what is the course I have to do right now. I mean, of course, you should do courses that you like, that you would be good at, and so on. But don't stress about it. Don't stress about it that if I have made a right choice of course today, then I will suffer in the future. Okay. And if you go through these, you will see they're very varied paths, right? So PhD maths, okay, uh, and so on, and then suddenly working for Siemens corporate technology in medical imaging, then coming back to academia. third one mainly in academia, but moving from maths to medical biology and then make mathematical biology and making a career in epidemiology out of that. Going from the fourth one, going from a PhD in function analysis to a first job at a bank and then to an insurance company, and now being a high-level risk manager for American Express. Doing a PhD working with genetic data, first faculty position in that, and then moving to data analyst at Allstate Insurance. Okay, and then the next one, which is really one of my favorites, BA Maths, then an MS in Financial Maths. Okay, so moving towards then working for Exelon Corp. Exelon Corp is an energy company in the northern US. It generates enough electricity to take care of a dozen Delhis. So it works on that scale. Okay. Now you would think, okay, so engineering company, right? So this should be electrical engineering and that sort of business. But there's a lot more. As an energy company, they own power plants of many types: nuclear, solar, coal, hydroelectric. Okay. So they have to operate all these. They all have their different characteristics. One of the things they face is that because winters are really cold where they operate, the energy demand in winter is very high. In summer, it is less. Okay, it may be changing now, but that is how it has been so far. And consequently, if they run enough power plants to take care of the winter demand, then in summer they have a surplus. And now these power plants either have to run at low capacity or they have to be shut down, some of them. Now these all become financial decisions, okay? And another thing is, do you really need to generate all your own electricity? Maybe someone else has surplus, you just buy it from them and distribute it. So that's another complication. So it turns out that to do all this, the energy company has to be an engineering company, and as well as that, it has to be a financial investment company, essentially. And the second part needs mathematicians and computer scientists and economists for them to work well. And so this guy with his maths training, he entered as a low-level sort of analyst, but then he was so good at the maths and programming side that he rose through the rank. He completely rewrote all their software, all their modeling that they used, and ultimately became the head of that unit, became the overall portfolio manager for them. Okay. And others remaining two are similar. So I think the point I would like to make is that today you cannot really tell, okay, 5 years from now, 10 years from now, what opportunity will come before you. You cannot possibly plan, in a fixed way for that. So just leave aside the stress associated with that kind of planning. Think about what you like to do right now. Okay, what would make you happy? Because then that is what you could become really good at. So think about what is it that you can become really good at. And if you can do that, then you will have an easier time moving to the next level, because that is the question people ask. Are you good at something? Okay. Because if you can be good at one thing, then I can believe that, okay, now you can transfer those skills. You know how to be good, you can become good at something else. So think more in those terms, okay? And just proceed. And keep your eyes open for opportunities. They will come. You try and take them when they come. Satya?
Yes, sir. Yeah, I'm that. Yeah. Yeah. Luckily, that slide now
Yeah.
got an opportunity to show me. Yes.
No, I knew there would be.
Yeah. Surely that will come up. Yes.
Now there is one more question on the YouTube. So the Mega asks, what is the best way to self-learn mathematics and make the most of a drop year, especially if we want to study MSc abroad?
I think my answer would depend a little bit as to what level this is happening at. Are we talking in school or college or masters, after your degrees, between degrees and job? But I mean, there are of course many good online sources. I think we didn't talk about them, but right, so you can go to MIT Courseware and so forth. So there's a lot to do. But actually, I would encourage anyone not to purely self-learn. Try and connect up with someone else, whether teacher or another student, okay, uh, and work together on things. I think what happens if you just study on your own, if you get stuck on a problem, you are stuck with your own thoughts, it can get depressing. So I would actually encourage anyone not to purely self-learn. Combine self-learning with some interaction with others so that you're working together on some problems. You have 2 or 3 minds working on it. And even if you don't solve the problem, it will be good for you to know that you are not the only one not able to solve it, right? It's a difficult problem. You couldn't solve it. Others also couldn't solve it. It's fine. So you will feel a bit better. Okay. Yeah, so I think when somebody comes to me and says they're taking a year off and they will, I mean, because students often do this, they feel they didn't study enough in bachelor's or master's. And if they could just sit for a year at home and study, then they'll be better off. And my thing is that this will be psychologically a strain. You will be isolated. Okay. So I don't encourage it in a very pure way. I mean, you want to take a year to strengthen yourself, take it. It's fine. Don't join a place formally. But then set up some informal structures, support structures, and discussion, ways of discussion that will help you out. Whether it's physically or online, but something. Don't stay isolated.
Yeah, I'll also agree with Professor Amber because you see, when we are going for a walk, you cannot go every day alone, right? Someday, friend or somebody is there, then you can go. Similarly, here you thought that I can read on my own, but there is no person what you are doing. There is no pressure on you. So little suddenly you are become little bit. Time goes, but there is no productive things will come from you. See, when you are doing your semester, there are 5 courses you are doing. But suddenly now there is no pressure, so you will be start relaxing or you don't know how to proceed unless otherwise very disciplined person. That's why it's our idea that try to have 1 or 2 people to interact with. So anyhow, I want to tell you that particular person that you can interact with us. MTTS Career Leaf alumni is available. You can give talks here. So we can so whenever you decided or somebody your friend is decided, so we can meet our Career Leaf members. So we are there at least for you to help. And so we'll plan in such a way that you keep giving talks in every week or so. Sometimes we'll record, sometimes we'll not record, or yeah, anything can we'll do. Yeah.
Yeah, and yeah, that's a great suggestion, Satya. I think that's very good. And just in general, I would encourage you, I mean, anyone in this situation to, then be a bit brave and reach out to people. At the most, they will not agree to give you time. But in fact, I think you may be surprised how many mathematics faculty are actually willing to give time if you ask them for it. We like talking maths, okay? And we like meeting people who like talking maths. So even if they can't meet you, they might give you time online. Okay. There are many students from MTTS or outside that I have met. Okay. One is not able to physically keep up. Once in a while, one chats online, does something. Okay. Uh, so if students are in Delhi, they have come over to my home on weekends for a chat. I have not taught them formally, but some friend has recommended they have come over. So look for things like this. And yes, Career Leaf, the opportunity it provides, I mean, that can be a great starting point. And then don't stop there, reach out to more people, things, then something will work out and you will benefit.
So there's one more question I want to ask. It's from the Google Forms itself. Can you elaborate a bit about data science as well as outline the pathway to enter this field after completing BSc in mathematics?
Okay, so I think, one is if you have completed your BSc in mathematics, there are actually, if you're sure that data science, I mean, there are two things. One is data science is a slightly undefined term. Okay, so it's not I mean, it's not like saying complex analysis or general topology. Data science is a very inclusive sort of term. All sorts of things are brought under it. Broadly, I would say that if you want to be a data scientist, your statistics, your linear algebra, at the bare minimum, these need to be very strong. Okay. So then maybe, and you have to think, okay, am I just wanting a job right now, or is this for the long term? I want a life in all this. Because if it's in the long term, then you can take a bit of time to become better at the kind of mathematics that's involved before you get into the job side of it. So look for programs that are strong in probability and statistics, have a bit of linear algebra and so on in them. You will also find master's programs that are officially called data science programs dedicated to data science. So, I mean, many such things are there. Or go for a MS that says applied mathematics. A general sort of applied maths degree is also good. Okay, because as you said, data science is very inclusive. So if you say I'm going to go data science, when you go for a job, very difficult to predict what kind of maths they will actually need. You might guess prop stats and linear algebra, but actually it might be differential equations, linear programming, or something like that. Okay, so I think a broad degree in on the applied side of mathematics would actually be a good idea to set you up well for the long term. But if you're in a hurry and you want a job faster, then go for a program that says data science, data analysis. Okay. Maybe a management degree with a data science specialization. It all depends on how technical you want to get in your own work.
Yeah, actually, as Sir rightly pointed out, it depends upon immediate joining. Then you also need to fix that which area you want to join. For example, if it is a medical, as Sir earlier pointed out, cancer patients or something, the classification techniques. So they are very specific to that one. We need some tools. Whereas in the long range you want to go, then pattern recognition and natural language processing. So we need to learn many other areas also. Signal processing under data science, signal processing also will be used. Pattern recognition in particular very much used. Data mining is used. So you want to become and you want to develop some own techniques, then it takes time. Yeah. So otherwise, if you want to immediately want to, then you need to fix up some area where you want to work, where data science is applied. For that, as Sir pointed out, basic concepts of probability, linear algebra, um, and statistics are very much needed.
Thank you, sir. Audience, if you have any more questions, you can put them in the Zoom chat box, or also the ones who are viewing us through YouTube live stream can put them in the chat box. So Deep Thakur has a doubt. Speaking of self-study, to what extent should one explore one's math research interest as an undergraduate student? Particularly, I have harmonic analysis as my research interest.
So in the harmonic analysis also, there is maybe a particular thing you may liking, right? That you need to pick up and start expository on that first. So then slowly you can read that in particular area who worked. You can look at those papers. It takes time. So in the harmonic analysis itself, you may like something. That also you need to recognize. First you understood that, okay, harmonic analysis I liked. In the harmonic analysis again, you may like some particular area. Okay, that may be related to eigenvalues, eigenvector side, or it person to person it varies, right? Then again in that again keep collecting things and present things and collect material and make an expository. Then start looking the paper that who already published in these directions and read those papers, elementary papers. Keep building up. So prepare on your own. So that expository keep on increasing. That is the idea from my side.
Yeah, so see, I think the issue becomes one of balance. Okay, because as an undergraduate student, you're supposed to be getting a general broad education in mathematics. And basically, most of undergraduate mathematics is unavoidable no matter what you want to do in the future. Research tends to demand that you let your mind concentrate on one thing for a while and not think too much about other things, right? So there's a bit of a tussle at the undergraduate level, in terms of doing research. That is why generally when undergraduate programs have research, one tends to tell the students, okay, first learn some maths for a couple of years, then think about the research side. I don't want to make an absolute rule out of this. I mean, there are some people who are just really good, really talented at a particular kind of thinking, and stopping them from that kind of thinking is maybe not nice. But as a general rule, okay, I would say that you need to pick up all the core mathematics and become good at it. So right now you're saying harmonic analysis. I'm not sure exactly what you mean by that, whether you mean Fourier series or Fourier transform, or whether you mean with finite groups, or you mean something else. Because harmonic analysis again is a large area and it could be anything. But one thing I would say is it's surprising how often different kinds of mathematics come together. So the danger with overemphasizing research at the undergraduate level is that then somebody just starts doing one kind of maths and becomes weak at other things. But eventually you might realize that the harmonic analysis problem we are getting into requires you to be excellent at group theory, which may not have been obvious at the start and you may have neglected it. Okay. My own PhD thesis took me in ways that I didn't expect at all. Okay. I was quite ignorant about algebra. I was basically into analysis and differential geometry, and my thesis started off like that, with differential geometry and harmonic analysis incidentally. Okay. But I discovered that way of looking at problems was kind of a dead end for certain problems. And by chance, I was looking at those problems. And you had to find a way to express the analysis as algebra. People had already shown the way, but then I had to take that and apply it to my situation. And so suddenly I had to pick up a lot of homological algebra and things like that, which I was not expecting to have to do when I started that work. Okay. And this happens with many people. So it's quite commonplace. Hard problems require you to think in new ways, and usually, often enough, that means taking mathematics which seem disconnected and finding the connection. Okay. All right. So by all means, look into what harmonic analysis means to you and research means to you, but don't neglect your core math courses. One day you will suddenly need them.
Correct. And even here, one of the participant is available here. So Ishan Das Gupta. So he's from the beginning, he's interested in category theory only. He's our student only, right? So he may share some experience if he wants, right? Ishan?
No, I think I agree with what Amber said.
Yeah, that's what.
Yeah. Deep continues to ask that I found that harmonic analysis is not as popular in India as compared to fields like algebraic geometry, which seem to be mainstream in India. How should I communicate with people interested in the same?
Okay, there's actually a very strong analysis sort of group, and harmonic analysis particularly. It will happen more in the Indian Statistical Institute, ISC. Okay, so maybe the algebraic geometry and the harmonic analysis people are sort of existing in slightly overlapping, but still on the whole in different places. But that's also, if you look at certain places, you will not see the analysts, and if you look in other places, you will see them. Particularly look at Indian Statistical Institute. There are lots of analysts there. The IITs have them, IIT Kanpur, for instance, Bombay, Madras. Okay, so you will find analysts in all these places. And there is, in fact, a discussion meeting for harmonic analysis that's held every 2 years. So, I mean, without knowing the person too much, but look into that. I think there is one this December. It's held in alternate Decembers. I think there is one this year. So if you know enough harmonic analysis, you could write to the people organizing it and see if you can get to go and visit this event. So there's exactly, there's a lot of harmonic analysts of different types in India. Okay, so we have a good history in it.
One of the student wrote that he's pursuing masters in mathematics and computing. What is it I need to do to get into computer sector and also to research? Yeah, so you're already in computing, mathematics and computing. So already you are, I think, doing courses related to computer science, it seems. But in the computing part, as you are doing, maybe for example, I'm just giving one example that marketing, that share markets, for example. So there is a company called Jiroda, right? So how Jiroda is working now? Look at that prototype, how it is doing. And there are many other, like many AMCs. They are called AMCs. So they are running mutual funds and many things, right? So many companies, they are using the mathematical techniques to build up their web pages and attract people, right? So mathematics and computing applications are there. You look at those things, then you will realize. For example, there is I'm telling specific example, KPIT. There is one company, so that takes care of mathematics and in the car auto drive and all. So that company is doing that. Recently, that company is doing very well, right? And the Tata Motors. So I'm telling a specific examples of where you can computing can be applied. Yeah, so you need to look into them and you try to, you may like one company and look at their expertise and develop that. And there are many companies of that type. You are looking one company and you're looking their expertise, but later you realize that there are many companies doing the same sort of thing. Then you are surely will be taken. If not sufficient, you can ask also. Oh, yeah, that's right.
Actually, I know on the practicals, one is what you should study. On the practical side, the issue is how do you get an interview with a company? That can be a problem in the sense companies are expecting to hire people, say, with CS degrees. And if it's a maths and computing or a maths degree, so are they going to look at you? So like at my university, once this problem, we understood it, and some of my colleagues, they understood it. Then basically they went and talked to the placement cell. Okay. And we had to sort of show them our curriculum. We had to convince them that our students are also good at computing. So when companies come and say, show us CS students, our students should also be allowed to join those interviews. Or at least, some companies don't agree, but at least from our side, we would make our best effort so that any company coming to look at, computing kind of students would also agree to look at the math students. And then it worked out for some of the math students. Okay. So maybe, on the practical side, you have to sort of see within your institution what's happening in terms of placement and advocate, get all the math students together and go and bug the department and the placement cell until they start do a better job of including you also. That you may have to do, okay? It happened in my university because the students first, came and complained, and then we started looking into it and understanding the problem.
So I don't think there are any more questions. So, sir, if you want to add anything else or present anything else from your side, you can do.
Okay. People must be tired.
Yeah.
It's fine.
So you don't want to add any?
Not much actually. So, but what we want to suggest is that you can interact with Curryleaf members so that we will plan, and so your ideas or your questions will help us to do some activities. So that will be helpful. That is what I want to add. So that is in higher studies education one can look at, or in the future we maybe one more session of this type we will try. So if you keep on asking question, then there is a chance that we'll get more ideas to have one more talk this way, one more session of this type. So we request you to communicate more to the Curry Leaf people and ask more questions so that will come up. Yeah, that's just
Thank you, sir. So now it's time to capture a glimpse of this talk. I would request everyone to turn your cameras on for a group photo.
Ishan, you have really trimmed your hair.
It cost 10.
Let me record now. Yeah, you can start.
Yeah. Thank you so much, Ambar sir and Satya sir. It is very common thing for a UG or PG student to get in a dilemma like what next, because the scope is very less known to us. Also, you had answered few PhD related queries or any other career related queries. So thank you so much, Professor Ambar Habib and Professor Satyanarayan. It was a remarkable talk, and I'm sure many must have been benefited from this talk. I would also like to thank the audience and the math enthusiast who asked a question, and we could have a discussion with the professors. Last but not the least, I would like to thank the anchors anchors for the day who made it. Also, I would like to thank my all Curry Leaf members and PTMT members, especially Monica ma'am, for their hard work to execute Curry Leaf Days 2023. Also, thanks to the viewers in Zoom, YouTube Live who has attended the talk, leaving India-South Africa match aside of the World Cup as well. We thank our heartfelt gratitude to MTTS Trust for always supporting us. Thanks to our advisor, Professor Satyanarayan Reddy. From depth of our heart, he is very kind to us, and he's very kind, always there to support us in every situation. Yes, thank you all. And if I've missed anyone, thanks to them also. Again, keep an eye in Curry Leaf social wings for further announcements. Thank you. Over to Asta or Shushma. Thank you.
Yes, so as Sangeeta Didi said that yes, we will recommend keeping an eye on Curry Leaf YouTube channel as well. So we are soon going to publish Virtual Student Seminar Program 2023 videos. And yeah, that's it from me. Asta, would you like to say anything else?
Yeah, I mean, Alapan Bhaiya will he has dropped all the social wings link, so I'll just recommend to follow all the social wings of Curry Leaf. That's it.
Thank you, professors.
Yeah.
Yes, Alapan Bhaiya, anything else?
Yeah, no, we're done.
Yeah.
Thank you.